Hello children, how are you all? Hope you all are doing well. This is VCHEM and welcome to Electron Chemistry Center. In this video lecture, we will be continuing with the states of matter. Long ago, we have completed Boyle's law. As you are aware of it, we were under the discussion of gas laws. Under gas laws, already Boyle's law is completed. Now let us talk about another gas law, that is Charles law. Charles law. That is another gas law. Actually, Charles law talks about relation between volume and temperature. So we must keep pressure and number of moles must be constant. P and N must be constant. Now the relation is established between volume and temperature. So what is the statement can be given? At constant pressure, volume of given mass of a gas. At constant pressure, volume of given mass of a gas is directly proportional to its temperature. Directly proportional to its temperature. So volume and temperature both are directly proportional. V is proportional to T. What does it mean? As temperature increases, volume also increases. Let us try to understand with the help of an experiment. If you take a glass bottle, you fill it up with normal or cold water and tie up with a balloon. The mouth of the glass bottle, tie up it with a balloon. And balloon cannot bulges whenever the glass bottle is filled with cold water. Instead of cold water, if you just fill it up, the glass bottle, with hot water. If you fill it up with hot water, what will happen? And the same thing, same experiment you are repeating. I mean to say that that glass of the mouth of the glass bottle tied up with balloon. Now this time balloon started to bulges out in all directions. So what you can understand, as temperature increases, gas starts to expand and that gas can enter into the balloon and balloon starts to bulges out in all direction. That indicates very clearly as temperature increases, volume also increases. So V is proportional to T, but the pressure and number of moles must be constant. So V is equal to K into T, proportionality constant, here K is, so V by T is equal to constant. If it is two different conditions, so I can take it as V1 by T1 is equal to V2 by T2, where V1 and V2 are initial and final volumes respectively, and whereas T1 and T2 are initial and final temperatures respectively. And this temperatures, when we are going to perform numericals, the temperatures must be taken in absolute scale. That means must be measured in kelvins, such a way. So V by T is equal to constant, we got it. It is statement 1, you can take it. But there is another statement, statement 2. We are going to talk about statement 2. What Charles' law second statement is, for every 1 degree centigrade rise in temperature, for every 1 degree centigrade rise in temperature, there is an increase in volume of 1 by 273 of its original volume. 1 by 273 of its original volume. Initially we have taken certain volume, that is called original volume, at a temperature, let it be initially 0 degree Celsius you have taken. So slowly you are increasing the temperature. For every 1 degree centigrade rise in temperature, there is an increase in the volume. That increase in volume is 1 by 273 of its original volume. So what I mean to say that, as per this statement, if you notice it, let us say volume at 0 degrees Celsius you have taken. Let us assume that volume at 0 degrees Celsius, in the sense that means, okay, you can take it as V naught, right? Volume at 0 degrees Celsius, that is V naught, of course 0 degrees Celsius, that is plus 0 you have taken. In a similar way, let us say you have increased the temperature of 1 degree Celsius. You have increased the temperature of 1 degree Celsius means this time Vt you can take it. So that Vt, that is of course Vt is nothing but what? 1 degree Celsius, right? Just wait. That is 1 degree Celsius. So V1, that is volume at 1 degree Celsius, will be initial volume is V naught. There is increase in volume of how much? 1 by 273.15 exact value, of course. If it is 1 by 273, it's approximate value. Exact value you can take it as 1 by 273.15 of its original volume. Original volume is how much? V naught. In the similar way, volume at 2 degrees Celsius, that is V 2 degrees Celsius, if I take it, what I can take it? V naught plus this time 2 by 273.15 into V naught. And it goes on. Let us say volume at T degrees Celsius. Assume that. Volume at T degrees Celsius will be Vt, which is in turn equal to V naught plus, here you will write T by 273.15 into V naught. Isn't it or not? So, hope you understood that. If I take it at T degrees Celsius, that Vt will be equal to V naught plus T upon 273.15 of its original volume can be taken. So, this is what we got it. Let us consider it as equation number 1. Assume that. Okay. Vt is equal to, we got it, V naught plus T by 273.15 into V naught. Now, this time what we are going to do? Vt is equal to V naught, and here you can take LCM of 273.15, and if you take it LCM of it, then what we are going to get it 273.15, that is T plus 273.15, isn't it? So 273.15, it is LCM, and we got it as T plus 273.15. Anyway, we have taken it is V naught, and then I can write it as this point. So Vt upon T plus 273.15, which is in turn equal to what we can write it, V naught. This one will be V naught, right, upon that is 273.15. But we are aware of it. This is T plus 273.15 in the sense that is Vt. That is T plus 273.15 means absolute temperature, because T degrees Celsius plus 273.15, and it is V naught. Of course, it is the temperature in Kelvin. So 0 degrees Celsius is equal to 273.15 Kelvin, isn't it? So V naught upon, it will be taken it as T naught. That indicates it is actually Vt upon T and V naught upon T naught means initial volume, initial temperature, final volume, final temperature. This I can write it as V1 upon T1 is equal to V2 upon T2. This is almost equal to the first statement of Charle, right? This is what we have given. Check it over here. So statement 2 also is almost verifying the statement 1. That indicates V2 by T2 is equal to V1 by T1 can be taken. So both statements are correct. Charle's law can be taken either statement 1 or else can be taken it as statement 2. Now let us try to take this equation 1. Once rewrite the equation 1. That is what we have given it. Again, I am rewriting that equation. Vt is equal to V naught plus 2 by 273.15 of V naught. This you can compare it with the equation of straight line. So that is y is equal to, right? This I can write it as y is equal to c plus mx. So I'll be taking that, T, temperature in degrees Celsius, but this temperature is in degrees Celsius, This I am going to take it on x-axis, and slope is going to become V naught upon 273.15, whereas intercept is initial volume. On y-axis, volume at T degrees Celsius, I am going to take it. of the graph, what we are going to get it, just observe it, right? Yeah. So this is volume at T degree Celsius, and here temperature, you are taking it in degree Celsius. If you take the temperature in degree Celsius, what will happen? Equation of straight line, if you compare it, this is the graph, you are going to get it. And you are trying to extrapolate the graph. If you extrapolate the graph, this curve is going to meet at this point. So here it's 0. And of course, this is negative temperature. Almost this temperature is in degree Celsius. And going to reach at a point called like minus 273.15 degree Celsius. It is the minimum possible temperature, lowest possible temperature. At this point, lowest possible temperature, this is degree Celsius. In Kelvin, it can be taken as 0 Kelvin, of course, right? And it is intercept. As I already mentioned, intercept will be V0, and slope can be taken. What is the slope can be given for this? Slope will be V0 upon 273.15. And 0 Kelvin, we have taken 0 Kelvin. That 0 Kelvin is absolute zero of temperature. Absolute zero of temperature. Where absolute zero of temperature means the temperature at which there is no existence of gaseous state. Because at that temperature, whatever the gas molecules which are going to exist, all those are going to convert into solid. In that case, there is no existence of the gaseous state at that temperature. Majority of the people commonly misconcept in such a way that the temperature has become negative. Volume and temperature are directly proportional. So volume would be negative. Volume will never be negative. Volume, okay, for suppose if you misconcept in such a way, that is meaningless. Volume will never be negative, right? So there is no existence of the gaseous state at that temperature. That temperature is called as absolute zero of temperature. So this graph is, graphical representation. We have given it for Charles law. Of course, whatever the graphical representation we are giving, all the graphs are called as isobars. The graphs which are drawn at the constant pressure. As you are aware of it, we are actually explaining Charles law at constant pressure, right? So at constant pressure means the graphs, whatever we are going to draw it, those graphs are called as isobars. So let us try to understand statement 1. Statement 1, that is volume and temperature, both are directly proportional to each other. Directly proportional to each other means obviously what we are going to get, it straight line passing through origin. And you are aware of ideal gas equation, that is PV is equal to nRT. So V is equal to, I can write it as nRP into T. So anyway, this is volume y-axis. On x-axis we have temperature. This will be m. So m is nothing but slope. What is the slope then? Slope will be equal to nr by p, can be taken. So you will get this graph. And similarly, second graph, generally graphical representation is very important in competitive examinations, right? If I take V by T versus volume I have taken. V by T versus volume I have taken. As you are aware of it, in first statement itself I have given, V by T is always constant. So if it is constant in the sense, and you will get a graph like this, it is also straight line, but parallel to the volume axis. And for suppose if I considered two different graphs, let us assume, okay, this is N1 and it is N2. Let us assume that. And if I ask you the relation between N1 and N2, that means how do you just demonstrate? PV is equal to nRT, isn't it? Then V by T is equal to nR by P, right? So, but nR by P, number of moles, for a particular gas, of course, constant, R is constant, P is constant. So V by T. But if I would like to demonstrate the relation between V by T and number of moles, R is constant, P is constant. V by T is directly proportional to N. That means whichever the line or graph is having more V by T value, that will be the highest N2 value. So the relation between N2 and N1 can be taken it as N2 greater than N1. Okay, hope you understood that. It's very important graph, of course. And I'm taking one more graph. This time also volume is on x-axis, sorry, y-axis, temperature is on x-axis. And let us say we got different graphs like this, right? And pressures are labeled P1, P2, and P3. If I ask you to relate that, then how do you say that? Slope is equal to NR by P. Do you agree? That means, okay, slope is actually, slope is increasing, let us say. Then what is happening? Pressure decreases. So slope increases, pressure decreases. That means relation between P1, P2, P3 for this particular graph can be taken as P1 greater than, P2 greater than P3. Hope you understood that. So such a way, Charles law can be demonstrated, and moreover, that is a second gas law. And graphical representation is very, very important. Hope you understood the lecture of Charles law from states of matter. If you understand, please click a like button, and if you did not subscribe it, please subscribe to my channel, and that would be a great support for me. Thank you very much, children.